Hello, everybody. This is second experiment we are going to introduce, and this experiment is known as Hooke's law, and this is very important to determine the elasticity constant of the material, and it's actually used generally for the mechanical properties of the materials. We need to know if we are going to act by external force on an object, if it will be permanent form or temporary deformed, or it will not be uh, affected by this external force. So the objectives of our experiment is to investigate the relation between force acting on a spring, and this is our material, and the extension of this spring. And this actually is abbreviated in measuring the elasticity constant of the spiral spring. So uh, if we have this spiral here, yeah, this, we need to know if we are going to affect by external force, what will happen to this spiral. So if this force is going in this direction, I mean, maybe there is a weight suspended here. This means this spring will be elongated in this direction, and if we increase the force, there is more of elongation, like this image here. So from this experiment, we are going to determine the elasticity constant of this spiral. And the elasticity constant is characteristic of each material. So Hooke's law states that if there is a force is applied to a spring, the displacement of the spring will be directly proportional to the amount of force applied. This means the external force applying to a spring, the displacement or the elongation of this spring will be directly proportional to this force. As this force increases, the elongation will increase. And if this force will be in the reverse direction, like a compressing force, this means that displacement is going to shrink more and more by this external force. So F here is known as spring force, and K is the proportional constant, and X is the displacement. Uh, so, what is the importance of this negative sign here in this law? This negative sign means this is a restoring force, and its direction is in the opposite direction of the external force. This means if the external force is going outward, the restoring force will be inward, and vice versa. So we need also to know what is elasticity. Elasticity is known as the tendency of solid material to return to their original shape after being deformed. Like if we have a steel and we are going to exert an external force, this means if this steel is deformed, this means it will be a permanent form because steel is not going to go back to its original shape. And if the steel is not deformed, this means it will not be actually deformed. So there is another term we need to know from this experiment is the stress. What is the meaning of the stress? The stress means there is a force applied to a cross-sectional area. And it means the external force will be divided by the area of acting. So stress is a force over cross-sectional area, and its unit is Newton per meter square. So as the force acting on our material is increasing, this means the displacement will increase. Like here, F equals minus KL, or F equals uh, K delta L, and this is delta L, and this is the spring in the equilibrium position. So after applying by external force, we are going to this, and there is an elongation, and delta L is the result of this external force. So if we made this force to be twice, this means this elongation will be also twice its value. So stress means an external force per cross-sectional area. So what is the term strain refers to? Strain is the ratio of a change produced in the dimension. This means this deformation that occurred, or this elongation occurred in this direction here, here. This elongation is delta L. And the ratio between delta L and L here is delta L, and here is L. And L is the original length of the spring in the equilibrium position. So the ratio between delta L over L, this means a strain. But this strain may be not only in one direction. Maybe there is some bulky material or some shear. So there are different ratios here. But the general formula says it's a change in the dimension over the original dimension. If this dimension is a longitudinal, and this means a longitudinal strain, so it will be delta L over L, like here. So delta L is the change in the length, and L is the original length. So what if it's a volume strain? This means it will be delta V over V. And here is the change in the volume. Like if we have a sphere or a ball that will be maybe expanded or shrinked by the external force. So this means delta V over V. And also the minus sign here means this volume is going to be shrink, or it will shrink. What if it's a shearing strain? So this is actually here is related to the length, and this is related to the volume, and this will be related to the area. But it's quite complicated. So according to Hooke's law, within the elastic limit, and we are going to know what is the elastic limit now. The ratio of the stress to the strain produced in a material is a constant. So this law is actually right in the range of the proportional constant. Like here, if we are still between point A and point 2, this is the proportionality limit, or this is the proportional area. If we pass from point 2, we are going to the yield point, and this means permanent deformation in our material. And if we continue, there will be making area, and at the final, there will be a fracture point where our material is going to be okay. So in this area, we are going to determine the elasticity constant, and there will be no permanent deformation in our material. So what is Young modulus? Young modulus, or the modulus of elasticity of a material, may be classified into three branches. The first is Young modulus, and Young modulus equals to the stress over strain, but it's related to the longitudinal or something in one dimension. So we are going to say there's a linear stress here, F over A. This is related to the stress, but it's a linear or longitudinal stress. And there is a strain, and it will be delta L over L, and it's related to a linear strain. So also there is the bulk modulus, and its symbol is P. And this means there will be a change in stress over strain. So there may be delta B over delta V over V. And in this case, this minus means there is uh, restoring force, or it will be shrinkage in the bulk or in the volume. And in case of modulus of rigidity here, it will be shear stress, which means F over A over shear strain here. So we are not going to do all this in our experiment, just we are going to determine it through a spiral or a spring like this. And you are going to exert an external force or applying an external force by using different weights. So this means the force we are going to act is F equals mg. So we are going to do different weights here. Maybe each weight will be 10 grams or 20 grams, and it will be small weights. So we are going to affect this spring by external force, and this force is abbreviated in different weights, and we are going um, to convert this m to f by multiplying g. And in this case, we are going to use we are going to use small weights, and this means we are going to use it 980 centimeter per second square. So let's go to the experimental work. And this is the setup of our experiment. This is our spring, and there is a pointer here to measure the change in the length. And here is the band, and this will be here. This 4 centimeters will be L, maybe L no. Like we are going to use this as a constant error, and also we may remove this from each reading we are going to record, but maybe we will consider it as a zero error and continue on our experiment without any problems. So we are going here to add some weights, maybe 5 grams or 10 grams or 20 grams by each reading. And each time we are going to record the reading, I mean the change in the length here. So if we add like 10 grams here in this span, this means this length will change it. It maybe will be 9 or 8. So if we made here 20 grams, this means this pointer maybe here, and it will be maybe 13. And we will continue adding different weights here, and then each time we're going to record or write down our change in the length. So this is the new length, and delta L will be uh, here. Delta L equals L minus L. No. So each reading, we are going to remove this L node, which will be not only here 4 centimeters. No, this L node will be the length, sorry, will be this total length here. Like this is from 0 to this, which may be this way. Well, this will be our first way. Second way is to consider this 4 centimeters here was 0, and we are going to actually no, this will not work. We need to know all these lengths, and in each time we will remove this L as L node, and we will remove this from this L here. Like if it was in the first reading 8, so and you are going to assume this totally here is 20 centimeters. This means this new L is 28, and L node means it was 20. No, it would be this 20 here, and here is 4, and this means this is 24. So maybe 28 minus 24. As you are going to say this is 20 is related to this spiral spring, and the weight of band caused this to be 4. So this totally means 24. And this is as an error in our experiment. It will be a fixed error, so it will not make any problems. So 28 minus 24. And if our second reading here is so if this second reading is 23, will be 23 minus 24. And this means delta L for the first reading and this delta L for second reading out, and we will continue in calculating our delta L. After all this, we are going to make a relation between this delta L and the force, or is external force. So we are going to plot this relation here. Will be the external force, which will be F equals mg, and here the extension, which will be delta L. And don't forget our units here. This will be in centimeters, and this will be in time, because this is a unit of force, but on the small scales. So in this table, we are going to record our data. This is F and this is delta L, which means we are going to remove this L node from each reading we are going to take here. Finally, we will find there is a slope here, and this slope equals uh, delta L over delta F, and this will equal 1 over K. This K, we need to know its value. So K, which is elasticity constant, our objective or our experiment objective, means 1 over slope, and its value is determined in line over centimeter, like here. K equals 1 over slope, and it equals 5 per centimeter. This is our experiment, and thank you for watching. Don't forget to share this video to reach for the others, and follow my channels for more of these videos. Thank you.